Okay, now, before we proceed to vector, let us have a recap about the coordinate system. Now, for the mathematics is the basic tool used by scientists and engineers to describe the behavior of physical system. Now, René Descartes, 1596 to 1650, introduced a system of coordinate based on orthogonal right-angle coordinate. In Descartes' system, the first coordinate value is the x-coordinate described where along the horizontal axis. Okay. The point is located. The second coordinate, the value, the y-coordinate, locates the point in terms of the vertical axis, which is known as the y-axis. Okay, this one is the y-axis, and this one is the x-axis. Now, a point with coordinates 4 and -2 is located, hey, before we go there, hey, in this figure, we have the y-axis and the x-axis. The first coordinate, this one, the sign for x and y, Always remember going to the right is positive, going to the left is negative, upward positive, downward negative. Therefore, here the sign would be positive, positive. And for the second quadrant, we have negative and positive. Why? Because your x-axis is going to the left while your y is still going upward. Now, for the third quadrant, we have the negative, negative. For the fourth quadrant, we have positive and negative. Okay. Now, a point with coordinates 4 and -2 given, points 4 and -2, is located 4 units to the right of the intersection point of the two axes. Remember, this one is your origin. That is the origin. Okay. What if the given point is 4 and -2? Draw, again, your x and y axis. Remember, your 4 is positive, therefore, your x is going to the right, while your y-axis is -2, therefore going downward. Therefore, this point is lying on the fourth quadrant. You have 4, 1, 2, 3, 4. And your y is -2, 1, 2. Therefore, this one is your point. From the origin up to that point, therefore, this one is 4 with -2. Okay. Now, Cartesian coordinate system. Cartesian coordinate system is the rectangular coordinate system. It's a system in 2 dimensions. 2 dimension, you have your x and y axis. Positive x is taken to the right of the origin and positive y is upward from the origin. Negative x to the left of the origin and negative y is downward of the origin. Kaya po you have your first, second, third, and fourth quadrant. Now, for the plane polar coordinates, r is the distance, given figure. You have your okay, this one. You have your r here. This one would be our r. Since lying on the first quadrant, therefore your y is going upward. You have your y. Then we have your x. Okay, this point would be your r theta. That is the hypotenuse. And then this one is the adjacent the adjacent side and the opposite side. Reference angle is your theta. Now, r is the distance from the origin. From the origin to the point having a Cartesian coordinates of x and y. While theta is the angle between r and a fixed axis, usually measured counterclockwise from the positive x-axis. Example. An example. Okay, the Cartesian coordinates of a point are given by x and y with value of 4.5 for x and y is 3.5 meters. Now, find the polar coordinates. Find the polar coordinates. Polar coordinates is composed of r and theta. Polar coordinates of this point using letter A, the graphical method. Letter A, graphical method. Okay. Condition, use 0.5 millimeter is to 1 meter. And letter B, the mathematical method. Okay, instead of 0.5 millimeter is to 1 meter, use 1 centimeter is to 1 meter. Okay, now using your protractor and ruler, you can find that your R is equal to 5.8 centimeter. Since the ratio is 1 centimeter is to 1 meter, therefore that would be 5.8 meter. And for the theta, you're going to use protractor in finding for the angle theta. Therefore, that is 38 degrees. Now, under the mathematical method, okay, since this one is a right triangle, okay, we're going to use the Pythagorean formula. Okay, according to the Pythagorean formula, the square of the hypotenuse is equal to the sum of the square of the other two sides. Therefore, we have r squared is equal to x squared plus y squared, where r is equal to square root. Okay, you have 4.5 squared plus 3.5 squared. Okay, your R now is equal to 5.7 meter. 0.7 meter. For the angle theta, under the trigonometric function, you have tangent theta is equal to y over x. Therefore, that is 3.5 over 4.5. For theta is equal to arc tangent 3.5 over 4.5, where theta is equal to 38 degrees. Okay, another example, 2 points in a plane have polar coordinates. Now, the given is the polar coordinates, not the Cartesian coordinates. Remember that the polar coordinates is composed of the hypotenuse and the angle theta, while the Cartesian coordinate is composed of x and y. Now, polar coordinates is 2.5 and 2.5 centimeter and 30 degrees. And the other point is 3.8 centimeter and 120 degrees. Now, determine letter A, the Cartesian coordinates of these points. And letter B, the distance between them. Using mathematical method and graphical method. Okay, first thing to do is what? Okay, to draw the figure. Okay, your 2.5 centimeter lying on the 30 degrees, first quadrant. Next one, 2.8 centimeter, 120 degrees. Okay, you have 2.5 centimeter and 30 degrees. Therefore, 2.5, 30 degrees. R is R1, 2.5 centimeter. Your R2 is 3.8 centimeter. Then 120 degrees. Okay, now, the requirement is to find the Cartesian coordinate of your R1 and R2. Therefore, you're going to find for X sub 1 and Y sub 1 for this one. And for this one, you're going to look for the value of your X sub 2 and Y sub 2. Then, after that, you're going to look for the distance between them. This one. Yun ang hahanapin. Now, since the graphical method, the values are, for X sub 1, we have 2.2 centimeter and Y sub 1 is 1.38 centimeter, while X sub 2 is negative 1.91 centimeter and Y sub 2 is 3.3 centimeter. For the R is 4.6 centimeter. Letter B. Now, for the mathematical method, we have your, again, for the figure, we have R1, 2.5 centimeter, 30 degrees. R2 is 3.8 centimeters, 120 degrees. 120 minus 30, that is 90 degrees. Okay, this one would be your R. We have your X sub 1. And then we have Y sub 1. Y sub 2. Like that. Correction. This one is Y sub 1, X sub 1, Y sub 2, X sub 2. Now for the graphical method, for your X sub 1, we have sine theta is equal to Y sub 1, Y sub 1 over R1. Therefore, we have sine 30 degrees is equal to Y1 over 2.5. Okay, where Y sub 1 is equal to 2.5 times sine 30 degrees. Y sub 1 now is equal to 1.25 centimeters. Okay. Then your x sub 1 using the Pythagorean, square root of 2.5, which is the hypotenuse, 2.5 squared minus 1.25 squared. X 1.25 squared. So x sub 1 is equal to square root 1.25 squared minus 2.5 squared. 2.5 squared minus 1.25 squared. Therefore, that is 2.16 centimeter. Therefore, we have 2.16 and 1.25. Now, for your y2, we have sine 120 degrees equal to y sub 2 over r sub 2. Okay, y sub 2 is equal to 3.8 times sine 120 degrees. Therefore, y sub 2 is equal to 3.29 centimeter. Okay. X sub 2 is equal to square root 3.8 squared minus 3.29 squared. X sub 2 is equal to 1.9 meter. Now, for the distance between them, we're going to use the formula for the Pythagorean. Since from the figure, we have this one, the distance between them is your r. Remember that this one is 120 degrees, then 30 degrees. 120 minus 30 is 90 degrees. Therefore, this triangle is under the right triangle. Okay, therefore, we have this one is your r, r1, r2. 90 degrees. Okay, the value of your R1 is 2.5. This one is 3.8. Okay, under the Pythagorean, we have R is equal to square root R1 squared plus R2 squared. R is equal to square root of 3.8 squared plus 2.5 squared. Your R is equal to 4.55 centimeters.